Blockspace is something we've been forced to believe with traditional blockchains that is a finite resource. I think wallets are the dumbest thing we've ever created in crypto. But I actually believe Facebook took a lot of the bullet for many of the industry today. Like, we would not have the progression we've had today if Meta did not really jump on a grenade.
Is it possible to scale the real business on top of blockchain? Imagine, it's Monday morning and you're just trying to send some money overseas to make payroll, but some kids somewhere start to bid up some random meme coins. Now the network is congested and you're gonna pay an arm and a leg to transact. With blockspace in short supply, this is no way to run a business. Meet Adeniyi, Chief Product Officer at Mysten Lab, the team behind the SUI blockchain. He started in finance, got orange-pilled in 2011, and ended up at Meta, where he met his co-founders on Project Libra. Their insight is that objects and not addresses are the right primitives. Taking objects out of blocks is the only way to build a scalable blockchain network. This is the exact opposite of containerization in shipping, where you lower transportation costs by putting objects back in boxes. To make their vision a reality, each of SUI's co-founders brought in one special ingredient: product, programming language, cryptography, compiler design, and consensus algorithms. Let's dive right in.
Yeah, so started off my career as a software engineer in oil and gas space. Then I went into finance because there's more money to be made in finance back then, right?
Sure.
I went to a very small startup, but finance was doing really well, and I thought, okay, let me. Interesting. My family, most of my dad's an economist. My brother's an economist. I like tech, but I realized the economists were right about the money. So I went over to finance. So I ended up building trading systems, risk management systems, algo systems for hedge funds and investment banks. In 2011, late 2011, I found about a technology called Bitcoin. And initially thought it was a scam, read more about it and realized this thing was brilliant. The code was a mess. But I saw a future where if we had this uniform view of the world, how much tech we could just delete, or how many headcount we're using in large companies that were completely obsolete. So I felt committed my life to that technology. Like, I wanted to build it. I accidentally actually built a company in the Bitcoin space. I ran one of the largest Bitcoin mining organizations in about 2012, 2013. So mined a ton of Bitcoin.
Hopefully you kept some.
I kept some, didn't keep it all, unfortunately, but it is what it is. Then I exited that company. I found a big data blockchain-based company that's around today, still in the Bay Area. Then got a bit disillusioned with crypto because I felt like things weren't moving forward. I felt like things were just really focusing more on the gambling aspect, right? More the speculative aspect, and less we wanted to move the technology forward. So I went to enterprise because I thought, okay, this will be an opportunity to actually build something really, really cool. So went over to Oracle, worked on Hyperledger, worked on a lot of getting Oracle Cloud blockchain out. Went over to VMware to do the same. And after that, went over to from VMware to Meta, where I led the product team on the research and development side of things. One of the best jobs I ever had, actually. Yeah, so that's a bit of my background.
Yeah, cool.
That's awesome, actually. Myself, I was also in Meta for the past 5 years, and Libra was one of the thought-after project inside it. It was very influential. Actually, could you tell us a little bit more about what happened there? What was the history of that?
Yeah, it's funny. I remembered my interview at Meta, right? Like, I had no clue what they were even building. So it was all shrouded in secrecy. I spoke to David Marcus, spoke to Kevin Weil, spoke to a lot of the leaders there, but I was more excited about just the idea of, I'd gone to the private consortium model. Now there's more of an open consortium model where Meta was trying to build, and I found, okay, well, they're going to solve the bootstrap problem. They had these amazing partners who are going to come in, and really, the fundamental problem Meta was trying to solve is, can we make sending money as easy and as cheap as sending an email or sending a message on WhatsApp? And once you can make the cost of these things low as possible, if not zero, the amount of economic development you can have, the amount of opportunities just completely skyrocket. So that was a vision, and they went through the consortium model to do that. At the same time, they also tried to launch a basket of currencies and had a peg, right? And I think that's probably the most contentious point of the movement, right? I think, exactly. If we're just focused on just a ledger, maybe using $1, it would have solved the go live issue, and then over time you can add disparate baskets. In fact, people can do that programmatically today. Nothing stops them. It's an element of a multi-billion-dollar company with 3 to 4 billion users. Giving everyone a bank account overnight was hard to take for people. So Of course, as people know, Libra didn't get to launch. But I actually believe Facebook took a lot of a bullet for many of the industry today. Like, we would not have the progression we've had today if Meta did not really jump on a grenade and try to get us out ahead of everyone else.
Actually, I think right now Tempo, Arc, all the new one is basically Libra.
Yeah, it's all a Libra remake. All Libra
exactly,
remake, yeah.
Exactly.
I think a lot of them are making the same mistakes that Libra try to make as well, but we'll see. I think ultimately what is most important is there's a big renaissance happening on tech.
Yeah.
People realizing having a uniform view of the world is the way to go. Yeah. And I think you're going to see a ridiculous amount of innovation off the back of that as well.
Yeah. I think you guys are famous for saying when you left the project, you didn't just go and do a rehash of what you done on Libra, and you did something completely different, right? So, and I think the main point is I realized that actually there's some technical limitation. There's something that actually is not built correctly. Yeah. Can you share a bit more, like what are the lessons learned and how SUI is set up differently?
Good question. So at Meta, we were trying to get Libra out in a finite amount of time, like really in a fixed period of time. So some of the amazing things we wanted to do, we had to kind of punt to version 2. So Libra was built to run on a consortium model, and you could only interact with a network using those intermediaries. You couldn't really interact directly, which means we did not need as much scale. So maybe 1,000 transactions per second, we could probably hit that and it would be no problem, but nothing much beyond that, right? So it would have worked for the mass majority of use cases where you have an aggregator that would take the transactions and then siphon to the chain over a period of time. We were working on something called FastPay, which is going to be Libra version 2.0. While at Meta. We never got to see that through. In fact, while at Meta, I was working on another blockchain called Trove, which is going to be, Treasure Trove was its name. A way for everyone, every post, every comment you make should be a content that you create and own. And your content is yours, and you can take it wherever you want. So that was the idea. And one of the big issues we saw with Libra was storage was highly expensive and not very parallelizable. So one of the design decisions we made when we left Facebook was to completely just do away with Libra entirely. All we took was the Move programming language, which was the biggest innovation we had, and improved on it significantly. And since we've left, we've redesigned the entire architecture from scratch, and we now have a highly scalable blockchain that has infinite block space. You don't have to worry about block space as an element of something that's finite, which is the traditional blockchains have that issue. But just like we build in Google and Facebook infrastructure, the more hardware you add, the more block space you ultimately get. So that element of horizontal scalability is something we do really, really well at the large big tech companies, and we've brought that into crypto, and we're still the only ones that have ever been able to do that at scale.
Hey, Zach in the editing room here. I realize that 76.8% of you have not yet subscribed to the Schelling Point. If you could just hit the subscribe button down below, it will really help us out and keep producing content like this. Thank you. Now back to the Schelling Point.
I think what you guys are famous for is the Move language is object-based, right?
Correct.
And because it's object-based, then you can also make it more horizontally scalable.
That's absolutely correct.
How actually, what's the link between the two?
So interestingly, when Move was initially built, it was an account-based system as well, just like Ethereum and everything else, right? And we saw an opportunity to redesign it when we left Facebook. And one of the things you rightly said is we made an object-based system. If you imagine object-oriented programming allowed a lot of code reuse and amazing abilities for people to build and innovate in software engineering. And it's pretty much run majority of software engineering now. Most programming languages are object-oriented, and we've taken advantage of that object-oriented model. We can model the world entirely using objects. Accounts and addresses is not how the world's modeled, right? So that paradigm is lost to a lot of developers. In fact, majority of developers, that idea and that paradigm is not normal. So that's actually what I feel stifled the growth of devs in Web3, because the programming paradigm is so alien. We took an object model because it's similar to the object-oriented concept. We believe there's going to be an asset-oriented world where everything is modeled around objects, but ultimately you can model the entire world. You can model an accounting table, you can model cars, you can model engines, you can model complex hierarchical structures using objects. So we feel that element also lends itself to high parallelization. So because you're not dealing with addresses where all the assets are on an address and you're trying to figure out which thing needs to go ahead of another, like how do you sequence things? because objects are independent, my object of $5 and your object of $5 are two independent objects, and they can be sequenced independently of each other because they have no dependencies. Me sending $5 to you is different from someone else sending $6 to someone else. So the more CPUs we have, the more things we can process in parallel. That is a new dynamic that's never been done before in crypto. And we're also seeing that the kind of composability that you get out of it is very, very amazing. So you can actually make applications composable. I can build an application. I don't have to think about APIs even to interact with. Or as long as there's an object model that you've built on, which is how SUI is built, you can interact with that app very freely. And it's the virtual machine that ensures the resilience of these objects.
I think composability is the promise of every blockchain today, so composability, but I think as you said, it's actually hard to do if you don't have this kind of framework. Because then, I think for Ethereum, you have shards and things, then it's very, very hard to reason how to compose across those infrastructures.
Yeah, I mean, Sam says it, right? Like, you know, in a world where code is law, interfaces are like a sin to a large degree, right? Like, you know, so it really with object-based systems, you know, the idea that I can take your object and put it as an entry function into my system, that is normal in object programming paradigms. So the idea that applications can interact using objects is actually not alien to developers. Developers fully understand that. This is why developers are finding it easy to build in SUI in 3 to 4 days, because they jump from C# or they jump from Java and they get this paradigm. There's no alien concept, right? Of course, there's balances and things like that, but these are just still object-oriented primitives. It's not an address primitive that they have to now rethink how you program and code.
So developers basically would focus everything around objects, and then all the transactions would be related to that. I think before you mentioned also about the fact that it makes the cost go down because all the transactions could be sort of aggregated around the object. Could you talk a little bit more about that? Like what actually, like how does it work? Like what makes cost go down?
Yeah, so I'd even take this cup and this phone, right? Like in the EVM world, right? You probably just have a box. Or in a traditional blockchain, so you have a box and all your assets inside a box. You can't really parallelize everything because it's all in the address. So you're having to take things out one at a time. You have no idea what relates to the other. There's no element of like, you know, being able to isolate an asset in a traditional blockchain space, right? But in SUI, I have a phone, I have a cup. They're two different things. So the operations I do on this cup have no relationship or dependency on the operations I do on its phone. So the more CPUs I have, the more objects I can process in parallel and tandem with each other, right? It doesn't mean the objects can't interact with each other, but at least when they interact, then I can sequence the interactions. But generally, peer-to-peer payments do not need consensus. So because we have an object-based system, majority of transactions don't even need to go through normal consensus because there's no element of, no one's going to contest that you didn't sign your transaction, for example, right? As long as the transaction is valid, you control the sequence, the system controls the sequence numbers, and you can progress the system. That is a true innovation, and that also means there is infinite block space on SUI. Right? So block space is something we've been forced to believe with traditional blockchains that is a finite resource. So what happens is, you know, whoever has the most money wins. So if it's almost like if you think about Lyft and Uber, right? Like whenever the network is congested, right? There are only a fixed number of cars. Well, we've got to raise the price, right? The problem with that though is at times like congestion, certain use cases die instantly, right? I can't pay $5 to send 20 cents because the network's congested. So I need to wait for the network to go back to a level that's reasonable for me before I pay. That is now the real world really works, right? So we can process as many up to 300,000 transactions per second.
Wow. Okay.
And as you need more resource,
Just
you
add
add
more
another
stuff.
piece of hardware. So we've shown in our papers that if you 8x the hardware, you 8x the throughput, zero increase in latency. So that's really, and the great thing about that is fees remain constant. So it's all supply and
predictable.
demand. It's all predictable. You know what the fees are going to be, and validators are incentivized to run the fastest hardware possible and to add more capacity as needed, or they lose their rewards if they don't keep up with the network, right? So it's a real system built not on scarcity but on abundance, and that I think having an element of infinite block space is actually going to allow a ridiculous amount of use case that you couldn't have before. We were talking about it before, right? Like in terms of shipping, as you said, right? When shipping was very, very hard and very expensive. The introduction of shipping containers, as you mentioned, right, ultimately means now got an element of like infinite block space, right? You can sequence as many things you want to ship as possible. As long as you keep adding more ships, you keep putting them in containers, you can ship as many things as possible. Now, for me to send something to China, send something to Romania, whatever, is not an issue anymore. I think it's the same paradigm with block space. Namely, you make it possible to send as many transactions as possible, you reduce the fees as low as possible, and then in lowering that barrier to entry, you actually onboard a lot more use cases that previously were not possible.
That's a great metaphor. Actually, we're just saying the power is actually the exact opposite if you think about it. Yeah. What made containerization valuable is you take a box, you put everything inside, it's easy to move. Correct. What you're doing is the opposite. Things in one block, because everything's one block, it makes it very hard to reason. Actually takes everything out, it makes it infinitely stakeable.
Absolutely.
But the point is it remains, which is how to drive adoption is lower the cost, make it easy to do. And an example you gave about congestion, can I agree more, right? Like how can you build a business where if someone have a viral hit like CryptoKitties, suddenly I can do any transaction, someone buying some picture.
Exactly.
Why would you care about it?
Exactly.
How does that impact my business? Which means nobody can run that at scale.
It's even worse, right? In a sense, if you say to somebody, hey, we could only support 50 applications. After 50, sorry, go somewhere else.
Exactly.
Or you could only be this successful, up to 1,000 transactions per second. But if you end up hitting a home run and building a really successful app, we'll destroy your business or we'll take it away from you, right? That is insane. That's not how you build any business, right? So you're meant to build a platform to allow people to succeed. That's the whole point of a platform, right? You're leveraging shared infrastructure. Our design ultimately facilitates that. Just because someone is minting a bunch of CryptoKitties or someone is making batch payments because it's Christmas time, right? It's got nothing to do with me. I need to spend 50 cents to a family member or $100 to a family member in another part of the world. So those are separate concerns. And natively, because it's an object-based system, they're treated separately.
That's very cool. I think another innovation that you guys also for storage, right? I think with Walrus, that you've introduced early last year, I think, or this year.
Yes.
Yeah. So that's also super interesting. Can you talk a bit more? Because I think storing stuff on blockchain also is quite expensive.
Yeah. So SUI is about 2,000 times cheaper to store a megabyte on than Ethereum, and about 200, 300 times cheaper to store data than Solana. So it's already super cheap to store data on SUI, but it's still super expensive, right? Because what you're really paying for is replication. So the network has 120 validators. So if you're storing megabyte, you're paying to store that 120 times. That is not efficient, right? So developers were asking us, okay, great, it's cheap, but still, it's not like AWS, right? Like, I still want the resilience of a decentralized network, autonomous network, but I don't want to overpay for it. I'm okay to pay a bit more because of the value that I get, but it should not be 2x, 3x, 10x. Right now, it's actually 100x, right? And this is SUI, not like ETH, which is like 2,000x, right? What we were able to do is rebuild a new storage layer that runs on SUI that lets you store petabytes, if not exabytes of data at the fraction of a cost, close to the cost of what you have traditional cloud service providers. So, you know, comparatively, we invented a new algorithm called we call it red stuff, right? And what it does is it basically will take a piece of data. Let's say this is your data. It would mathematically run some computations over it and split it into billions of pieces and spread that using something called Eurasian encoding over any number of nodes in a network. And the end result of that is to recreate my data, I'll only need to talk to a third of a network, right? So let's say 2/3 of the network is out of business, I can still recreate my data. So it's actually higher resilience than AWS. AWS will give you, 3x replication, 4x replication, 5x replication. That is just replication. What we give you is resilience over thousands of machines, and you only need to communicate with a third of a network to be able to recompute the data that you have, which is, and then only the maximum amount of replication you actually get in the system is 5x. So, so
your cost is predictable.
Your cost is very predictable. So it's 5x replication on the data. Okay. But if you compare that with AWS, it's giving you like 3 to 4x, right? The cost is actually really comparable.
So regardless of number of nodes, it's still up to 5x.
Correct.
So for developers, it's good, right? You're saying basically you're not overpaying 2 orders of magnitude, only 5x.
Only 5x.
Developers say, it's good.
It's from 4 to a maximum of 5x depending on the data. So you're only ever going to pay for 5x replication, but If you have 200,000 nodes, it will still be split. It will still use consensus to split that data across the 200,000 nodes. It's only going to be 5x replication.
And also to read it, right? To retrieve the object, only
Correct.
1/3, right?
Only
so
a third.
even if half of the network goes down,
Correct.
still could get it.
Correct.
Oh, that's awesome. And so everything is achieved based off this cryptographic way to split the data and then reconstruct it back.
Correct.
No, that's awesome.
So it's an entirely different way of thinking, right? Where not a single organization runs your storage, you run it yourself. And then we've now launched a new feature called Seal, right? Of course, blockchain is public data. You're storing data on a public network. Anyone can read it, anyone can access it. But what if you want to have private data sets? Or you want to have monetization behind data sets, right? The biggest use, 60% of the builders on SUI, on Walrus actually AI builders. And they're generating interesting data sets that they want to monetize. And with Seal, you can encrypt that data on-chain. And only by you could set policies as to what can gate access to information. I can gate it by payments, I can gate it by royalties, I can gate it by entitlements, I can gate it by any kind of information, right? And it's fully programmable. So I could say, as long as you're part of my consortium, you can download this piece of data for free. And if you're not my consortium, you have to pay some fee. So it's fully programmable. What that now means is you really get DRM on chain. In a sense, right? So you can have public data sets, you can have private data sets, and you can gate the payment mechanism directly from a single smart contract. So here you have a world where a single smart contract can control storage, it can control transactions, it can control payments. It does all that in a single smart contract language, which is what we wanted to do at Facebook. We wanted this single layer that lets you control all the amazing things you want to do on the platform.
What makes it so powerful? Is it that object-oriented feature?
Correct.
Makes it so
So
powerful?
it feels like objective was the key decision.
It was a key decision,
That's
right?
the key decision, effectively.
Yeah, it's a key decision. The blob of storage on chain is an object. The payments that you've made, the subscriptions you have for that is an object. So you can rationalize around the world with an object-based system, but it's hard to rationalize. You're building these crazy abstractions when you have an address-based system or an account-based system.
And then I think the metaphor with the container is perfect. It's the opposite of container, but it's the roots of everything. Like
Correct.
basically everything we talk about is only possible because you made that decision at the beginning.
Yeah.
I think there's another thing also that you guys talked about, which is really interesting, which is how do you onboard massive user, right? And I love what you said, which is nobody wants to use wallet.
Yeah.
I think a lot of people use wallet today. That's how you onboard the first few, right?
Yeah.
But the early adopter are not going to be the general user. And can you explain more how the zKLogin works?
Yeah. Back and say, I think wallets are the dumbest thing we've ever created in crypto. So, I mean, this idea that, we've invested billions in user research in Web 2, and Web 2 has built amazing user experience. And then we decide to undo that with a decision that, hey, people need to create a private key and store this paraphrase under their bed, mattress, some cloud. Like, who thinks like that? So, and then on top of that, you tell people, oh, before you can interact with a network, go and buy a token on some exchange. Like, it makes no sense. Like, we already know the cost of user acquisition. You were at Facebook. You know the cost of acquiring a user is very, very high. And then you then kill it by putting a high barrier of entry from the user. It's like the business decisions that are being made in crypto are nonsensical at times. So what we were trying to achieve at Facebook was, can we build something called unilateral payments? Like, and the idea is that, can I send money to anyone in the world, but not require them to sign up for a service to receive it or redeem it? That was the premise behind it. We were semi-successful in trying to make it work. Myself, Kostas, and a few of the team at Facebook, but it still had some crypto notion in it, which I felt was overtly cumbersome. But we were able to make a breakthrough. Kostas made a phenomenal breakthrough at when we left Meta on zKLogin. And the idea of zKLogin is, can we just let you use your existing Web 2 identities to transact on the internet? Can we do that, and can we do that privately, right? Like, it's great that I have a Google account, Facebook account. Why should I have to get another account to interact with the blockchain? So we will take your session that you have with Google, and we will generate zero-knowledge proof over the session cookie and create a temporary key that you could use to sign transactions. And we can verify that session. The chain will verify that's a valid signature. It doesn't need to talk to Facebook. It doesn't need to talk to anything. It does that using certificates that are stored on chain directly. So that notion means any Web 2 account or OpenID account can act as an address on chain with SUI. And it's fully private. I remember we spoke to the team at Google as well, right, about this. And one of the amazing features of it is Google has no notion of what transaction you're signing. You want to maintain, you want to leverage the power of existing identities, but you also want to make sure users gain privacy from the underlying identity provider. So you'll not be able to tell on chain that this is a particular Google address or whatever it may be as well. So even now, the great thing too is you can just tell me your email and I can email you money. and only your email address can claim it. So imagine that with Facebook too, right? Like I know your Facebook username or your Facebook ID, I'll send money to our Facebook ID, and instantly you can claim it. So
That was the original promise of PayPal. PayPal technically was sending email, but it was much
Yes.
more complicated behind
much
it.
more, a lot of mechanisms in the back
Exactly,
end.
exactly.
None of that is needed with zKLogin.
Oh, it's amazing.
This.
And then the other thing that you mentioned also, that's because we got involved to some degree with confidential computing.
Yeah.
And the idea is in the shipping industry, sometimes what you need is a group of people collecting data together to compute some statistics.
Yeah.
Nobody wants to share the information because it's very private, but the overall statistic that you can compute is valuable. For instance, performance,
Yes.
things like that.
Yeah.
And you have this thing called Nautilus with
Yeah.
a trusted execution environment. Can you tell me more what is it about and how you use it?
I mean, you nailed the use case right there. Like, one of the problems you have, right, is you want to generate computation over private data sets, and you don't want to reveal everything about it. The options you have are homomorphic encryption, and that stuff is very expensive and not generalized enough to be really applicable in the real world. We're doing some work there with a team called Eco there, but that's still a long time away. But one of the best known ways to do that is actually secure computations with enclaves. So in a world where you have SUI, you have Seal, you have Nautilus, you can coordinate the sharing of information across disparate organizations and collect that information in a trusted enclave, trusted computation engine that could give you average, mean, mode, median, maximum, give you aggregated information over that computed data, and you can prove that computation was right using Move smart contracts as well. So you now have a world where you can take private data sets, generate computations of our private data sets, publish the results online or privately and encrypted using Seal and Walrus, and leverage your decentralized infrastructure to gain access to federated infrastructure as well.
Is Nautilus the point of Nautilus running stats analysis, or is to run AI model potentially also?
You could use anything. So if you want to do decentralized inference, if you want to run long-standing jobs that exceed the limit or budget of a traditional smart contract, you could do that using Nautilus. So if it's AI, if it's standard computations, if you want to build Oracle services and things like that. I mean, we have onchain randomness, but if you want to build Oracle services as well on top of that, you could leverage Nautilus to do that. So it absolutely solves those use cases.
And you can fully trace the supply chain of data, where the data come from, who gave it, what's the calculation, and prove it.
You can prove it. You could, not only that, but you can prove that the right computational function was run over that data, which is what matters. You want it's trusted execution. You want to trust that execution was done correctly as well. So it's a lot of guarantees that you get.
And is it insured by hardware, like because it's trusted execution environment, right?
Yeah. So today it's supporting the Amazon standard for trust execution. There's going to be NVIDIA. NVIDIA has their own trust execution as well. We're going to add more over time. So you may want to have employ any number of different trust execution environments. We'll be able to support any one of those.
Another project I think you guys are working on, super interesting to me, I mean, as ex-trader, is DeepBook.
Yeah.
Right? So tell me a bit more, how do you try to achieve a central book effectively, but in a decentralized manner? Because I think that's the promise of DEX, but in reality it's never done exactly the same way, right?
Yeah,
the right way.
So blockchains fundamentally have very low bandwidth, right? Yeah. So their ability to process a lot of transactions in a very finite amount of time, especially in the parallel notion, is near impossible. Yeah. So what they do is they use mathematical formulae to kind of mimic the behavior of a central limit order book. Yeah. For those who don't know, a central limit order book is it's almost like what you trade on when you go to NASDAQ or Coinbase or whatever. The element that you can provide very deep liquidity for some trading pair and ensure you get really fair execution of your trade. So I can specify what I want to sell at, I can specify what I want to buy at, and that specification is what is called market making. Right? You can get really efficient tight spreads if you do it really, really well. Now, in a world where you have low bandwidth, giving people the ability to put trades in and out as fast as possible, quoting prices, is not possible. You can't do that on ETH when the gas fees are so high, and also the block space is so limited. Similar to other blockchains, right? The same problems, as the gas fees are really, really high, parallelization doesn't exist because most blockchains are sequential systems. And really, the element of just being able to do things at very low latency is also not possible as well. So how do you do that on a blockchain? Well, if you have an object-based system with low latency, SUI's end-to-end finality is in the range of 398 milliseconds. Optimistic finality is about 25 milliseconds. So it's very, very low finality for a fully decentralized system. Next year, it's going to be close to 200 milliseconds. Could we build a order book that mimics the performance of a Coinbase, of an IMEX, or any one of these traditional exchanges? The answer is yes. DeepBook is exactly that. So what DeepBook is, it lets you trade at the same speed you want to trade on traditional service providers, and fully permissionless. You can trade whatever you want to trade. You can create your own pool, you can create your own trading pair, but market makers are, because SUI has this notion of this feature called PTBs, which is programmable transaction blocks. It lets you effectively transact, up to 1,024 heterogeneous transactions all at once atomically. So let's say, for example, I have 500 trades on chain, and the price has moved against me. Yeah. I want to cancel those 500 trades and put another 500, just like what market makers do all the time, right? To follow the market. On Ethereum, you can't do that. One at a time. You get
you just need one by one.
And something called MEV. Something called MEV would take you out in time. Even if you did it programmatically, something called MEV would take you out in time. Yeah. On Solana or any of these networks, right? The same problem, right? With SUI, you can, in a single transaction, remove those 500 trades, replace with another 500 instantly and atomically. So if you want to trade in and out position really, really fast, you need these atomic primitives to work. Yeah. You don't even get that atomicity on traditional service providers or cloud, or you don't even get it on like Coinbase or NASDAQ, right? So here's a paradigm that a public chain gives you. The atomicity of trade using heterogeneous transaction processing, using PTBs, and do that directly on chain. So it is a highly efficient order book. Market makers love it because they can get in and out of position as fast as possible. They can quote more frequently, which means spreads are going to be a lot tighter. And also the cost of transacting, to do 10 transactions and 500 transactions on SUI is almost the same price, right? If you use PTBs. So your marginal cost of trading is very, very low. So this is the element of what SUI has and other chains don't have. And another great thing about DeepBook is over 15 to 20 different DeFi protocols are built off the basis of it. So they all leverage it as a form of liquidity. Even DEX is built off DeepBook. If their price is off, they can go to DeepBook for liquidity and source it and get better pricing. So it's an amazing story around composability. Anyone can build on it. Anyone can build a front end for DeepBook today. See it as a back end. And in fact, a few firms, a company called Deep Trade has actually built a front end for DeepBook. They didn't build the online DeepBook engine, but anyone can build a DeepBook front end, and it's stored on Walrus. So it's fully decentralized front end, fully decentralized back end.
Wow,
that's interesting. Yeah. And then, you mentioned a little bit about time to finality, right? I remember before it was something like you need to have 2/3 of the network plus one transaction. Has it changed in any way? Because you mentioned that time to finality keeps decreasing, right?
Yeah. So for a Byzantine fault tolerant system like SUI, you need 2/3 of a network to agree to propagate a transaction to be final. Unless you're doing, fast path transactions, right? Remember I mentioned these transactions are peer-to-peer, I'm using an object to your object. You don't need consensus for that. Yeah. It bypasses consensus entirely for that. So it's instant. Those transactions happen in less than 500 milliseconds. They're instant. And anything to do consensus, it used to be up to 1.5 seconds. Now it's down again to less than 500 milliseconds. So both fast path transactions and consensus transactions are down to in the 398 kind of number. And next year we'll be down to 200 milliseconds. It just keeps getting faster and faster.
Is it advancements in technology? Is it advancements in cryptography?
So it's advancements in how we propagate messaging, and how we verify. Because SUI is it's a dynamic acyclic graph technology. It's like DAG, right?
Yep.
So we're using a DAG-based consensus mechanism that's actually being taught at universities now. Because the first one I could actually understand. Most of the things are above my head. I could actually get this one. But we keep innovating and improving that a lot better. So it's advancements we keep making on DAG-based tech that keeps allowing us to move forward.
It's very interesting because very personally, when coming from finance, I don't think there's a need to go to like 1 millisecond, like the lowest, because I think at some point there is a diminishing return. Like we need everyone to be HFTs, right? HFTs to run on. But at the same time, I think you're absolutely right. Is if you cannot have some a fast decision like within the good time spent, it's actually hindering the liquidity and then the market.
Think about it, right? Like Solana is about 13 seconds end-to-end finality, right? Like if you're a trading firm or market maker, you don't care about optimistic finality. You don't want to assume your trades have gone through. You want to know your trades have actually gone through. So you cut that down to something like SUI, which is 398 milliseconds finality. And you have, we have block speeds of something like 68 to 70 milliseconds, right? So you can get notified of your block being final very, very quickly as well. So these elements are what you need for high frequency system. So yeah, as you're right, like there comes a number where like there's no
Doesn't matter anymore.
Doesn't matter anymore,
right?
right? Ultimately. So, but yeah, it's we believe this is going to be the future of decentralized finance.
Yeah, super interesting. Actually, we talk about a lot of the feature on SUI, but one question I want to go back to, maybe it's not business vision of SUI, right? Which I think both you and your co-founder are talking about. The idea is the decentralization. You want to bring decentralization to everything. And personally, I would kind of make the argument that maybe decentralization is not needed everywhere. So one example, today we're shooting a podcast. Most likely the episode will go to YouTube. And actually, I think having YouTube as a centralization agent, not from a technology perspective, but to create the market, is actually beneficial. I would hate to have 15 type of YouTube, one for history type of podcast, one for the makeup podcast. You just want one where everybody can meet. How to balance the fact that not everything should be decentralized?
Yeah, I don't believe everything should be decentralized, right? There, for example, if what you're looking for is simply trust, especially trust in a group of organizations, argument is, why do you need to do that on a public blockchain? You can have a system where transparency is key, and information is shared cryptographically to those who need to know. There's no need for a decentralized arbiter of that, right? So I always say you need to look at a business case, like what problems are you trying to solve? And there are paths that lead you to a story of you don't need decentralized, and there are paths that lead you to you absolutely do want a decentralized platform, right? Like I just think it's use case to use case dependent, and it's the way we see things as well. Like I participate a lot in what we're working on, the Hyperledger Fabric, for quite a while. And there are perfectly legitimate use cases, especially in the shipping industry, where you really just want a network for partners to interact with each other and do that in a trusted way. You do not need a public network to make that work, right? And yeah, like I totally agree with you in that sense.
And I think so far you've identified probably three, so DeFi, gaming, and commerce. Can you explain more, like how do you guys?
So what for us, for one, we're an open platform. People can build wherever they want on the platform, right? But the area we find compelling is where composability matters. If I want to leverage what someone else has built in an open market, then decentralization is certainly the key. It's almost like open source software, right? Like open source software, you've opened up the APIs, you open up how it's built, I can build on top of it. It's the same element of doing that in real time before applications in production. So, if I'm a gaming company, the fact that there's a payment rail already available to me, the fact that there's a stablecoin already available to me, the fact that there's an app store that I can fork or literally program into or list my assets directly into is valuable. It means I don't have to build 5 or 16 different pieces of technology. At that point, my cost of onboarding is significantly lower, and I plug into an existing ecosystem of users. So there's a reason where decentralization makes sense in those use cases. And the DeFi, I would say DeFi isn't a product, it's infrastructure, right? The fact that there's this market that people can trade and facilitate trade autonomously between each other. A game may want to leverage the ability to allow you to buy and sell in-game assets. Are they going to build their own market? Why not just leverage an existing market that has it for them, right? Or someone's already got the code base. So this is an element where I think composability becomes super valuable. We want a composable internet. That's what we're trying to build at Mysten Labs, right? A world where, our rationale for SUI and the SUI stack was the internet is going away where we have a lot of silos for apps, and APIs are only creating complexity. If we can remove the need for APIs and allow apps to communicate using objects, then we have composable applications, and you can build amazing businesses from there. That's it. And there are use cases that absolutely need none of that. You know what I mean? And there are use cases where those things are the whole true and absolutely paramount.
So was it the case that you come up with this composability first principle and look in the verticals where they could be applicable?
Absolutely.
Or did you look at this vertical has a pain? How could we solve it? Like,
so certainly it's a bit of both. First, I think composability has always been paramount because we believe in the ethos that that's what's going to allow things to move forward, and it's going to allow the velocity of development to be very, very high, right? And the element will also be, we have this high-performant blockchain. What industry onboards users as fast as lightning? and also is willing to innovate as fast as possible. Gaming is obviously one of them, and finance becoming another as well. So it just seems to lend itself really well to that. Gaming pushed how we redesign data centers, how we do immersion cooling, how we do develop GPUs. It pushed a lot of work we're doing in AI. So gaming is always very quick to adopt things, even new business model transformation, right? On free-to-play model, ad-based models, and everything else as well. So we're finding a lot of wins and success in gaming.
Yeah. Actually, I was going to say, when you say shipping, it doesn't need decentralization. Actually, I disagree. Actually, shipping as an industry is an industry where people want choices. The fragmentation is a feature, meaning I'm a shipper, I want to have contract with multiple shipping lines.
Yeah.
I want to have multiple freight forwarder, which by definition is I don't want to be tied to a single one.
Yes.
So I resonate completely what you're saying, which is composability very important because we need to give you superpower. You solve this problem, compose with this one, then you can solve more complex product. The other one I think that you talk about already, which is stablecoin, I think payment. I think Swift just yesterday announced that they're going to build a blockchain settlement layer with 30 banks, given whatever.
That is very interesting.
which is very funny. And I think for me the choice was more, they chose 30 banks globally, right? Yeah. So it's what is more interesting is the banks that didn't make the list of the 30, right? Because it tells you the band of Swift.
Yeah.
But I think recently you made an announcement with the Google, right? With the app to pay. Can you tell me more? What is the rationale? I think it's agent-to-agent payment.
Yeah.
And how do you think about this use case using SUI?
Yeah. So for us at Meta, we saw a future where the majority of interactions you do in the future is going to be led by autonomous agents on behalf of users. When we left Meta, I mean, this LLM stuff hadn't taken off as much, right? We thought we're still way off, but we also knew in that world you need ability to do things atomically, especially from apps. If I have 55 applications, right, and then an agent needs to navigate 55 different apps and needs to execute transactions between them, if it has to do sequentially and it comes back to you say, oh, I booked your flight, but sorry, there's no hotel. Sorry, the flight is not refundable. You're going to be pissed. You know what I mean? That doesn't make any sense, right? So our ethos behind that is build a system that autonomous systems can build on. And our partnership with Google is exactly that, right? In fact, our demo with Google showcases that you can enable agent-to-agent payments and do that atomically. That feature I talked to you about recently called PTBs, they were able to show that on SUI you can cryptographically sign and execute n number of transactions instantly atomically on SUI. This is not possible on any other platform, right? So that's going to matter in a world where applications are programs, right? And the way you interact with them are strongly typed objects. How do you ensure that all these things execute your demand at the same time and not leave, side effects as we call it, right? So it's a very strong use case, and we think agentic payments and work we're doing with Google and AP2 is the way forward. There'll be any number of standards, I think, on payments, and I think for our point of view, we always want to be there as the infrastructure that can facilitate payments. We have a unique superpower that we just think other chains don't at this point in time, especially in the public blockchain space.
So we've talked about a lot of use cases and a lot of exciting stuff happening. So what's in store for 2026 for SUI?
2026 for us is developer growth. In the last 2 years, SUI has been the fastest growing decentralized dev platform in crypto. And the last 12 months alone, both SUI and Solana have superseded other ecosystems. So we're only 2 years old compared to Sol and other ecosystems. And it's because Move is so freaking easy to learn. So people are picking it up really quickly. And now we have SUI, we have Seal, we have Nautilus, we have DeepBook. We have what we feel is.
Is anything missing? Is it something you think that's missing to make it?
We only know when something's missing when we get developer feedback. So some of it is intuition, but my intuition tells me that we are nearly complete on at least the feature side. Now, there's going to be decades of improvements and additional functionality that you add on top of that. But you've got CPU, you got storage, you got RAM with SUI, Seal, Walrus. You've got Nautilus, you got encryption, you got everything you need now to start building full stack applications. We call it the full SUI stack. And what we have to do now is just start onboarding devs at a rapid rate. And I think that's going to be what the next 2-3 years is all about. Onboard devs, let them build something they've never been able to build before.
Yeah. I think one feedback potentially, right? So what we learned dealing with the shipping industry is general purpose infrastructure is important, but at the same time is the industry will have specific dynamics and type of use cases which then gives the developer the ideas, how do I build something specific for this? Yeah. But it's kind of interesting because you both need to communicate the benefit of the infrastructure, but also see the ideas actually you can use this for your use case for this industry.
For sure.
I think that's the difficulty.
Yeah,
That is
yeah.
that's the part that's actually quite challenging.
You need example code. You also need to plug in your code base into as many LLM or developer platforms
Correct.
as possible. The way people consume information today is largely different.
Yeah.
I think you win this by a bit of bottom up and top down.
Yeah.
You've got to win in the hearts and minds of developers. You also need to show the business case.
Developers.
Yes, yeah, absolutely. So we're doing a bit of both in that front, right? So the partnerships we announce, some of them are very top down and some of them are very bottom up.
Yeah.
So the metric we want to drive now is really just that developer growth.
How many developers is on SUI right now?
We're one of the top actually in terms of monthly actives. In terms of like monthly active devs, I think SUI is over 1,000.
Okay.
Mm-hmm. So, and it's funny, we keep saying, if you look at crypto has something like 28,000 active developers.
It's peanuts.
Facebook had 50,000 developers. So people used to say, EVM is one, and this is one, that's one. They don't know how traditional
They don't know scale. Yeah, they don't know
like
the
there are
scale.
over 15 million developers on the internet. And you're talking about 20-something thousand devs. So we're going after those 15 million internet developers. That's what we're going after. Yeah. So it's not hard for us to supersede any traditional crypto platform, but we're not competing.
You're not competing in the same
Sol.
space.
We're competing with internet dev platforms. That's really what we want to win. We're looking at the use cases that you build on Google that you start to build on SUI. Not everything you build on Google or AWS goes to SUI or the SUI stack. There'll be elements of resilience you need, fault tolerance that you need, programmability that you need, openness that you need, that I think those use cases will naturalistically translate to the SUI stack. And that's our focus over the next, over the lifespan of a business.
And if you also go back to the same thing, right? Choosing object as the most important primitive makes your programming language easier to learn.
Yes.
Which then drive this. So it feels like the key decision was the object.
That was
the
most important decision we ever made.
Who made the decision?
It was a combination. Actually, my founders, Sam, George, Costas, worked on it together, and as a result of that, it actually lends us to allow us to do things like path optimization. We can do low latency end-to-end finality transactions. We can do batch processing. PTBs won't be possible without an object model.
Exactly.
There's just so many things that it opens up the door for us to do. And you can't redesign your system after you've already built it to be an object system, right? We've seen people try, it just doesn't work, right? So
it's really great that you started from those first principles, look at that from scratch, right? Not looking at existing solutions and start building on top, and then
That's true. I mean, this is also the reason why we're confused on VCs, right?
They
didn't know what box to fit us in. And we're not building an L1. We don't know what we're building yet, but we know we want to build a bunch of protocols to fix the internet. We don't know what it's going to be. And wait, what is it exactly? Sorry, we draw your graph. We don't know what it looks like. So
the line diagram, we do this.
But we were bold enough to say, hey, we don't know. And we want to go back to first principle thinking about that. And that was a difference for us, right? It was highly risky. But I'd rather do that, and if I had to make the same decision, we'll do the same thing over and over again. We're just so blessed that we have a very strong team that can actually build these things, right? It's one thing to ideate, but it's another thing to actually execute, and I think execution's been one of the things we've done very, very well.
It feels like it's also very unique, because I think typically VC won't fund a startup with 5 co-founders.
No.
Right? that's a recipe for disaster.
I wouldn't fund the company with 5 co-founders.
It's typically a group 5 would do breakup. There was some tension, right? So how did it come to be? Is it you have to thank Facebook to gather you 5 people together, work really hard program and build trust? Is that how it happened?
We've worked with each other for years and we've built a lot of trust. We know how each other works. We also come with different skills, right? I'm a product person. Of course, used to be an engineer, but thank God I don't write code anymore. Sam is an inventor of new programming language, and he's our CTO. George is our chief scientist. He invented a lot of the consensus stuff that we built at Facebook, and we acquired his company at Facebook to build Libra, and he leads a lot of our R&D. Costas is our cryptographer. For me, he's the top cryptographer. The stuff he keeps inventing on a regular basis, no one's got the output that this guy has. And Evan, the LLVM that allows your phone to work, he's the major contributor to that.
Oh, wow, okay.
And he won an ACM Computer Science Award for that work, right? So our phones would not work if it wasn't for the work Evan did. So we have a disparate set of team that work on different things, and it's a very complementary skill. And that element of knowing systems, programming, cryptography, product, you name it, all that merged together to actually build what I feel is the best platform that exists today. One person missing would not have got us to where we are today, quite frankly. We would not have zKLogin if we didn't have Costas, right? You have this amazing tech, but there's no way to actually reason about how to use it really, really well. We'll not have object model if it wasn't for Sam and George, right? Like, we'll not have fast path execution if it wasn't for George. There's just so many things that we're missing if you didn't have this dynamic of 5, and we're still here. You know what I mean? We're still here. Yeah.
Yeah, actually, no. I think just before we recorded, you were talking about Silicon Valley, the show, right? So you say someone is like Eric Bachman. So we won't say who. It's not very nice for him.
we have a Bachman for sure. We absolutely, and I forgot the founder's name.
But then which one are you?
I don't think I fit.
Always.
Well, actually, maybe if I'm honest, I have to be the weird guy.
The weird guy,
the BD guy,
the BD
right?
guy?
If I had to like boil it down, I have to be the weird BD guy, right? That tries to put us, okay, let's think about how this thing really works. How do people really make use of it? But generally, I think I'd say this is the best job I've ever had.
Yep.
The second best job I ever had was actually working at Meta on Libra. So it's great to work with the same amazing people I worked with on Libra and now in a new company. So it's been phenomenal.
Yeah.
So,
Cool.
yeah.
Awesome. Thanks a lot.
Yeah. Thank you very much, guys.
Thanks a lot for your time.
This was great.
Thanks a lot.
Thanks so much, folks.